Okay, we're going to keep the video tonight short and sweet. Let's talk about acceleration. Acceleration is on page 23 of your notes. Let's go. All right, so acceleration, we can talk about acceleration. We can also talk about deceleration. The deceleration meaning that you are slowing down. So acceleration is the change in velocity occurring over time. Acceleration is measured in meters per second squared. Now, one thing to make note of, you are not squaring the actual value of acceleration, just the seconds are squared. So really, acceleration is meters per second, but the 2 seconds combined. So meters per second squared. The seconds are squared. However, you are not squaring anything unless it is in your equation. Acceleration goes along with velocity. Velocity is a vector, therefore acceleration is also a vector, and vector means direction. So you need direction when talking about acceleration. All right, so we have 4 situations right there on your page talking about the direction of velocity versus acceleration. So the direction of velocity and acceleration do not have to be the same. They can be different, as you see. So the first, we have a positive velocity and a positive acceleration. The car is going to speed up in a positive direction. So here's your car, and it's going to speed right up in the positive direction. Remember, in physics, we talk about the right as being positive, left as being negative. Your second situation, we have a negative velocity and a negative acceleration. So negative velocity, negative acceleration, we're going to speed up in the negative direction. Our third situation, we have a positive velocity. So the car is pointed towards the right. And we have a negative acceleration. What's going to happen? Well, this car is going to move. It's going to end up slowing down. And eventually it's going to speed up in the negative direction. So in the direction of your acceleration. So he's going to go backwards. Think about being in reverse. So pushing a negative acceleration, you're backing up. You want to go back. So you're going to speed up backwards. And our last situation, we have a negative velocity and a positive acceleration. We are going to do the opposite of what we just saw, and we're going to eventually speed right up in the positive direction, going along with our acceleration. So this car is going to speed up to the right. We have 2 equations that we can use when talking about acceleration. So the first is that for your average acceleration equaling the change in your velocity over the change in your time. Remember that triangle, that delta sign means change. So change in your velocity over the change in your time. Acceleration is the rate of change in velocity. When you see the word rate, rate means time. Rate means time. Every single time that we talk about rate, that we talk about these equations, you will hear me ask you that. Rate means time. So the slope of a velocity time graph tells what the acceleration is doing. We talked about that in the last video. We talked about that when we talked about the velocity time graph in the velocity speed video that you watched prior to this. So the slope of your velocity graph is acceleration. The second equation here, the third on your reference table, represents this A equals delta V over T equation, except it's expanded. This second equation, we call this equation the Vitat formula. And the reason for that is we have VI, your V initial. This represents your VF, your final velocity. But your VI, V initial, plus, which kind of looks like a T, AT, acceleration times time. So VI, TAT, Vitat, it's just a way to remember it. Whenever I ask you about what equation should we use, a lot of you are going to call out Vitat, and this is the equation. So this equation is going to come in handy for a lot of different units that we cover. It helps you to bridge different topics together. So your VITAT formula, VF equals VI plus AT. An object's velocity at any point in time can be found by considering its starting velocity, its acceleration, and the amount of time over which it accelerates. Now, do keep in mind, acceleration, we could talk about deceleration, and deceleration is negative. So your acceleration absolutely 100% can be negative.